Hello and welcome back to my channel. Today I have another amplifier for dyno run, and this time I have an Infinity amplifier and the model is reference 5761A. So the manufacturer specifications are 56 watts by 4 and additional 2 times 107 watts into a 4 ohm load that was measured with 1% of THD and at a voltage of 14.4 volts. It's possible that we have lower results because I'm testing the amplifier at 13.7 volts DC and not 14.4 volts. The amplifier features 3 LEDs. One LED is a power indicator. On the left you have the protect LED indicator, and on the right you have a clip indicator, and that wasn't common back in the days, and I think it's a nice feature, and we will have a closer look to the clip indicator. Here we have the power connections and the speaker connections. It's easy to bridge it. You can see it from down left to upper right. You can make the bridge connection. There you have the high-low pass filters of 12 dB per octave, and it's variable from 32 to 320 Hz. There's a bass EQ knob for the sub channel that gives you a boost from 0 to 12 dB at the frequency of 50 Hz. Input sensitivity is from 6.3 volts to 75 millivolts. Let's start the dyno test. This is a 6-channel amplifier. I'm running out of power resistors to test the amplifier with all 6 channels driven into full power. I suggest that I do 2 measurements. The first one is testing with only 4 channels driven into full power, and the second test is with the subwoofer channel driven into full power. The first test is 1 kHz continuous power with 4 channels driven into full power without loading the subwoofer channel. Here we have our signal, 1 kHz. Clipping, I go back, take a screenshot and try to find out the maximum voltage, the peak voltage. We have 42.8 volts. With 42.8 volts, the amplifier delivers 58.5 watts into a 4 ohm load, 4 channels driven into full power without loading the subwoofer channel. Let's have a look how many amps the amplifier pulls out of the power supply if the 4 channels are loaded with 4 ohms. We have 28.1 amps. I calculated an efficiency of 60.7%. Continuous power test, 4 ohms, but this time with a 50 Hz input signal. Too much. 41.6 volts. Even with 50 Hz, the amplifier still delivers 55.5 watts into a 4 ohm load, 4 channels driven into full power. I just want to demonstrate the function of the clip indicator. You have this LED on this position, on the center position, and the LED to the right here is a clip indicator. Now it's really off and we have a clean output signal. Now I go into full brightness of the clip indicator. It's going brighter now, full brightness here, and you see the signal is clipped. It's a nice feature. Now I'm checking the amplifier for dynamic power with 20 cycles, 1 kHz. And here we have the first cycles look very good. I go straight to the last cycle. Looks also good. And I take the highest peak voltage is 43.2 volts, all cycles at the same voltage level. With 20 cycles I have an output power of 59.5 watts into a 4 ohm load, 4 channels driven into full power. And now testing with 8 cycles. Here we have it. All at the same voltage level. We have also 43.2 volts. Now I'm testing the subwoofer channels. I have them bridged mono 4 ohms and all 6 channels driven into full power. So we have 47.2 volts. With all 6 channels driven into full power, the amplifier delivers on the subwoofer outputs 139 watts into a 2 ohm load. Now I repeat the continuous power test again with all 6 channels driven into full power, but this time I can only do the 50 Hz test because the subwoofer channels are only working up to 320 Hz. And here we have a voltage of around 40 volts. We have 40.4 volts. Even with all 6 channels loaded, the amplifier still delivers 52.3 watts into a 4 ohm load. Just for comparison, I'm now testing only the subwoofer channels without a load connected to the fronts and to the rears. Oh, too much. We have 29.6 volts. With 29.6 volts, the amplifier delivers 112 watts of continuous power into a 4 ohm load per channel, both subwoofer channels driven, without the fronts and rears loaded. Now I'm testing the amplifier into a 2 ohm load per channel, 4 channels driven without the subwoofers connected to the amplifier. So I'm testing into a 2 ohm load with 1 kHz. Clipping, I go back. And I have an output voltage of 36.8 volts. The amplifier delivers 86.8 watts into a 2 ohm load per channel, 4 channels driven. Dynamic power 20 cycles. There's no dynamic headroom. Dynamic power with 8 cycles. But we see there's also no dynamic headroom. We have the same 36.8 volts. All cycles at the same voltage level. I can raise it a little higher. Then you see I got higher voltage in this position but clipped. So in this case I just test with 1 cycle to get the maximum peak power out of the amplifier if I see that there is some dynamic headroom. And as we saw at the 8 cycle test, we could see that the first cycle was way higher than the others, so I just test with 1 cycle. Now we can squeeze out a little more maybe. Oh yes, we can. And I have a peak voltage of 39.6 volts. With 39.6 volts we have around 100.5 watts into a 2 ohm load, 4 channels driven into full power. Now measuring the current, the amplifier is pulling out of the power supply with 4 channels loaded into full power with 1 kHz continuous power. And then we have 45.8 amps. 4 channels driven into a 2 ohm load, the amplifier has an efficiency of 55.3%. And now I'm testing just the 2 subwoofer channels, bridged mono 4 ohms, that means I test for 2 ohms per channel, both subwoofer channels driven, without the fronts and the rears loaded. Clipping, I go back. And I got a peak voltage of 48 volts. That's 147.7 watts into a 2 ohm load per channel, both subwoofer channels driven into full power, without the fronts and the rears connected. So we meet almost the manufacturer's specifications, but remember I just test at 13.6, 13.7 volts and the specs of the manufacturer were made at 14.4 volts. Now I'm testing 2 ohms per channel, all 6 channels driven into full power. That means I connected the scope to the subwoofers and I adjusted the gain on the amplifier to have the signal just right before clipping. I did this to the fronts and I did this to the rear, so I have the same behavior on all channels. That means the load of the amplifier is equal and the point of clipping is also equal. So now I'm testing 2 ohms per channel, all 6 channels loaded into a 2 ohm load with 50 Hertz. .4, 33.6. Let's calculate with 34 volts. If the amplifier is loaded with all 6 channels driven into full power, the amplifier still delivers to the fronts and to the rears into a 2 ohm load per channel a power of 74 watts. Let's have a look at the amplifier's efficiency. How many amps is it pulling if all 6 channels are driven into full power? Wow! 81 amps. If all 6 channels are loaded to the amplifier with a 2 ohm load, the amplifier has still an efficiency of 52.1%. The amplifier has a nice temperature. It's not super hot, but it's warmer than warm. It's warmer than my power resistors and the efficiency is 50%. I'm not going to try a 1 ohm load test. That's bullshit, especially on a 6 channel amplifier.
Thank you very much for watching. See you next time. Bye bye.